Hello everyone, my name is Amparo Lopez and I am professor at the Hydraulic and Environmental Engineering Department at Universidad Politécnica de Valencia. Today we will be speaking about action and reaction hydraulic machines and which is the difference between them. So when we finish, we will be able to understand the difference and the reactions in any sort of, in any case of pumps and turbines between action and reaction machinery. So we are speaking about reaction and action in hydraulic machinery. What for? The action machines, reaction machines, and finally we will conclude. So there is a ratio relating this behavior in hydraulic machines. This is the degree of reaction ratio that can be defined as a parameter for multi-stage of turbomachinery relating the ratio of the static pressure in the pump head and the total head. So as the static pressure and the dynamic pressure are complementary, we can have two definitions of this degree of ratio of reaction, directly relate to pressure or indirectly relate to velocities. So it depends on the velocity triangles and the transformation inside the impeller. If a big transformation is in terms of pressure, we will have a big degree of ratio of reaction. If a big degree of energy is made in terms of velocity, we will have a small reaction ratio. So it depends on the actions occur inside the impeller. A degree reaction of 0 means there is no increase in pressure within the impeller, constant pressure impeller. Whereas a degree of reaction of 1 means that the static pressure increases inside solely in the impeller. So we have several machines in any case. So how are action machines? Action machines are machines in which the flow, the water, moves the turbine by direct impact on the impeller blade. So we have, like in this case, the water taking more and more static pressure, and then they go at a 0 pressure because it's atmospheric conditions, and this flux moves the impeller, like in this case, with a direct impact in the impeller, but no change in pressure inside the machine. It is important to have a high waterfall height, so it hits as hard as possible in this case, because this is an action machine. For example, in this case, like this is the kinetic energy moving the system of the impeller. In this case, it is converted in kinetic energy, while the pressure inside and outside the system is the same. So the most used machine taking in care of this principle is what we call the Pelton turbine, which is a very strong, very capable machine to produce a lot of energy due to kinetic transformation. In this case, like this, we see a real Pelton turbine. Apart from this, we have the reaction machines. In this case, the direction of rotation of the impeller does not coincide with the direction of entry and exit of the water. In this case, these turbines use kinetic and pressure energy to move the impeller, and the pressure at the outlet is different than at the inlet. For example, in this case, the reaction machines. In this case, we are making the machine to move as a consequence that the movement of water is transformed in pressure inside the machine. In this case, the distribute surrounds the entire impeller and being the total water intake. For example, in this case, we can have the Copland turbine, which is a complete reaction machine that works by sending up the lead force generated on the impeller when the flow passes through the machines. This can create excellent progress in small hydropower plants or many other applications, and a direct, very direct reaction machines using velocity way of proposing energy. So, as a conclusion, we could say that we have considered the difference between reaction and action machines across the degree of reaction, the ratio of reaction, and the nature of the relationship between the flow, the pressure inside the machines to be considered of action and reaction. We have presented several examples of one or another, and we hope this is of interest for you in this sort of hydraulic objects of learning. Thank you very much indeed.